from day one, we're thinking about how are we going to be able to integrate this into real capabilities and build something that our warfighters can use. The global standard seems great until you have to change it. When you have something that, say, an entire service agrees on, trying to change it means it touches a lot of players, and it can take a lot of effort.
Thousands of companies show up to sell their technology to the U.S. Department of Defense each year. But so few will transition from proof of concept to true production across the valley of death. The select few who do, their stories are rarely told. Until now. I'm Noah Scheinbaum, and this is Crossing the Valley. Apogee Research is a small organization many of our listeners will likely never have heard of. It was founded by Evan Fortunato, an entrepreneur who moved into the defense industry after 9/11 brought national security to the fore. Today, Apogee works on some of the hardest technical problems facing our government, and they do it as a services firm. Today's guest is David Gerson, the company's vice president, responsible for managing all of the company's programs. David has worked on some of the most interesting and difficult challenges that we face as humanity. He's quite literally a rocket scientist who worked on propulsion at SpaceX. He was also the president of the Global Space Balloon Challenge, a high-altitude balloon event designed to inspire the next generation of scientists to aim higher. And he's been a major part of driving this little-known team that's had a major impact on the Department of Defense, including in one of our most opaque yet important areas, interoperability. In this conversation, we talk about Apogee's business model, working with DARPA, and one of the most impactful DoD transitions in recent memory, the Stitches program, which makes it easier than ever for disparate defense systems to communicate with one another. I hope you enjoy it. Let's get to it. Really excited today to have David Gerson with us. He's the vice president at Apogee Research, a phenomenal shop. We're gonna dive deep into a variety of topics today. David and I have not known each other for too long, but I've known of Apogee for some time, and some of the programs and the projects that Apogee's working on are really at the forefront of modernization efforts throughout the Department of Defense. So, David, thank you so much for being with us. We're excited for the conversation.
Thanks for having me, and thanks for everything you're doing, trying to both raise awareness and help folks figure out how to navigate the defense ecosystem.
Absolutely. This is going to be fun. So from, some of our listeners may know Apogee, but you all actually have an interesting strategy of actually trying to stay a little bit smaller and stay below the radar. So let's start there. What is Apogee, and what is it that you all do?
Yeah, so I think it's useful to give a bit of background on the company. So Evan Fortunato, who's our president and CEO, started the company in 2011. Technically, it founded. He started with his partner Tiffany, and then he did a stint at DARPA, and then moved over in 2014. And Evan and Tiff got into defense after 9/11. They were doing other things. 9/11 happened, and they were like, national security is important. This is where we want to spend our time. They joined a small company called Alpha Tech that was in the DARPA ecosystem. It was a fast-growing, very innovative company. Eventually got bought by BAE, one of the larger defense companies. And Evan was at the smaller company, then joined BAE, larger company, sort of moved into the business arm, then took a step out, went to DARPA. And at DARPA, he was working on an important program that was very responsive to a urgent need from PACOM. And he was able to pull together two communities that really didn't interact and figure out how to bridge that gap and solve a problem that others had thought was impossible. And coming out of that, he wanted to start a place that could really focus on solving the problems where people looked at it and said, we would really give anything to have this, but we don't think it's possible. But if physics says there was no reason you couldn't do it, we wanted to look at those problems and figure out how to address them in a new way and bring together a team of across many different disciplines to solve those problems. And so that's really what we're here, is to solve problems that would help revolutionize the defense space, but that are hard for the current incumbents to do for one reason or another.
Really interesting. So when you talk about hard problems, these are hard technical problems. You're not taking commercial technology and just kind of green painting it or kind of making it purpose fit for government. You're talking about things that are theoretically at the bleeding edge of technological innovation with direct military or defense applications.
Absolutely. And we're not trying to reinvent the wheel, though. We're leveraging things that are deeply baked into the community. So, for example, a lot of what we do is leveraging compiler technology and the ideas of domain-specific languages that have been in the commercial world for a long time and really haven't been applied to the DoD in the same ways. So we think about it as taking cutting edge ideas from many different industries and fields and bringing them together in a way that they haven't been brought together before. And then combining that with a deep understanding of the defense problems. And that's really where our sort of niche lives.
So fascinating, right? And someone like you, who's, I think, like a literal rocket scientist, right? You were doing really kind of cutting edge work at SpaceX before. What brings someone like you, who's now been, you've been at some of the biggest, fastest growing companies in the world. What brings someone like you to Apogee?
Yeah, so a lot of it was meeting Evan and hearing his perspective on how to problem solve differently and how to approach these very multidisciplinary problems. And part of what I think got me excited about Evan was his ability to say, I've convinced myself that a solution exists, and then be willing to dive in and go after it even before he knows exactly what the solution looks like. And he has a track record of doing this and people being like, you're crazy, this is never going to work. And then it pans out. And the chance to come learn from him how he does that and then also try and solve some of these really important problems for the defense world was really attractive for me.
So it all comes back to people. So good folks and getting to work on really hard problems. Really interesting. But maybe you could start by giving us a little bit of a sense of what is the Apogee model. And maybe we start with, how do you all decide what problems to work on? Because Lord knows there are quite a few that could use people like you, especially in the defense world.
Yeah. So as I said, they have to be problems that we think are very impactful for the defense community and ones where we think we have something unique to add. So in general, that means that we're focused on the software side of things. A lot of us have backgrounds in hardware, but with our current company and the size, innovations in hardware are a bit more complicated. So we tend to focus on the software side of things. And we focus on problems where we have partners that are going to be able to help us solve the real issue. And those are partners both on the government side, where there's customers who really want to go fight the fights that someone in the government will need to fight to change how the government does something, as well as partners on the sort of bigger prime side who are really going to be able to help drive the transition and drive the adoption. And when we find that, that's what points us in a direction. We're like, great, we have customers who really want this. They're willing to help us make this happen. And we think that it aligns with what we're trying to do. The current focus is really on how do we do heterogeneous distributed systems that are going to be resilient in contested environments, because that's where the big conflicts are headed and where we think there's a lot of technical problems that need to be solved to open a new way of fighting and building weapon systems.
So those are a lot of big words that some folks here might understand. A lot of listeners have come from the military or the defense space, but there's also some folks tuning in who really are just learning about the federal market for the first time. So when you talk about heterogeneous, complex systems in contested environments, what does that mean to a layperson?
Yeah, so I think that there's probably a few key pieces. First is, you can't assume clean slate. So when we say heterogeneous, the DoD has dozens and dozens of companies building capabilities, and those capabilities span decades. There's top-notch radios that we built and used from 50 years ago. The F-22, which is still one of the best fighter jets in the world, was built a surprisingly long time ago, which means that there's hardware assumptions and software assumptions that we take for granted in the commercial world today that don't necessarily apply. Because in the commercial world, we can think about it as, well, we sort of throw away our smartphones every couple years, and no one's trying to use phone technology from 2000 or even 2010 today, whereas the DoD, we're trying to integrate hardware from the 70s all the way through to today. So we can't assume clean slate, and we need to figure out how do you bring everything along and be able to integrate and enable new technology. So that's one piece of it. The contested environment piece is important, and it's really a statement that the adversary gets a say. That when the DoD is focused on is how do you operate at wartime, when there's an adversary who's trying to deny whatever it is we're trying to do. And in the commercial world, there are versions of that, but it's very different when you're going to be going up against a nation state. And one of the other things that's important to think about for the DoD is that the U.S. is usually trying to project power to stabilize things in other places, which means we're not playing on our home turf. And usually that means that there's an adversary who's been able to spend lots and lots of money building up their home turf, usually specifically focused on denying the U.S. capabilities. So whether that's being able to jam U.S. comm systems, be they satellite or sort of tactical radios on planes, being able to have missiles and radar systems and other things designed to counter U.S. stealth or aircraft carriers. And so this idea of the adversary gets a say, and the U.S. is operating in an environment that is fundamentally hostile to what we're trying to do is really important to think about and drives a lot of what we do and how we try and approach these problems so that we're not making assumptions that won't hold when we get to an actual fight.
Yeah, no, I think it's a really unique challenge set, right? It's something that's a little bit different than, say, if you're, I don't know, running a commercially available software package where most of the time, there isn't somebody actively trying to kill you, for lack of a better word. So what that allows you all to do is to say, hey, we learn a bunch from the commercial space. We deeply understand kind of the mission needs of this particular customer, which is the government customer. And we kind of bring all of that together to try to build solutions that will work. The longitudinal view, that chronological view, that's saying, hey, we're actually integrating something from 1970s. I mean, like if you don't update a program for a couple of weeks, whether it's Apple or Microsoft, they start yelling at you pretty consistently, right? And I think we'll talk a little bit about what sustainment means in a government context. But for now, we can say it's not that simple, right? It's not you don't get the push alert, update your software all the time in government, and everybody does it. And I think we can't underestimate the degree to which that presents a pretty unique challenge.
Exactly. We often say there's no patch Tuesday. It's not that every Tuesday Microsoft pushes a set of updates that goes and updates everything concurrently. Because if you're in the middle of a war and there's a set of deployed systems, the last thing you want to do is push those and update that might break the very capability that warfighters are using.
Yeah, that's a good point. So David, one of the things that you guys are known for is that the work you're doing is not just for it's not just for the lab. It's not just a science experiment, right? You guys have an eye towards transition, which is why we're talking in the context of this show, even from the beginning. And we'll go through one of the examples of one of your, I think, highest profile successes in a little bit in the form of Stitches. But talk to us a little bit about the development model and what it means to be building from day one for transition. How does that inform how you all approach problems?
Yeah, it's important. I think it's one of the things that separates us from others in the DARPA ecosystem and in the defense ecosystem writ large, where from day one we're thinking about how are we going to be able to integrate this into real capabilities and build something that our warfighters can use. One piece of that, and I think this goes back to the idea that of things being clean slate, is that we try and build humble services. There's services that you don't have to change your system to use our technology. Our technology adapts to your interfaces, your workflows, so that you can get incremental value and build as you go, rather than needing to do some big bang, tear everything up, replace it with our software, which isn't going to be practical for many, many reasons. And the second is that the DoD is structured often with a lot of different workflows. That, for example, there are folks who understand systems engineering and how do you compose new capabilities, but they don't necessarily understand software and memory management and things like that. You have a lot of folks who are very good at the software development side, but might not necessarily understand how to think about tactics and how to think about bringing together different capabilities to actually achieve a mission effect. And so rather than trying to build capabilities where you need that unicorn, you need that one person who's phenomenal at 100 different things to be able to use it. How do you build different pieces that let folks who are good in their areas play their part and have it all come together as a larger whole? And I think, as we'll talk about through Stitches, that's been one of the things that has been most critical and has allowed us to build something that is easy for folks to just pick up and use without needing to learn entirely new skills or throw out all of their current approaches and start over.
So building, I don't even know if it's a team of teams, but it's a team of disparate players who each have kind of a zone of expertise, zone of genius, bringing them together and giving them a container to be successful. I love that. Let's one more thing on kind of Apogee itself, because I think as some people are listening to this, there's a lot of companies that set out to build solutions for defense, and there's a lot of different ways to do that. There are the companies who go out, they raise a bunch of money, say, hey, we're not even going to focus on selling for a little while. We're just going to focus on building really great product. There's others, so called out the venture-backed approach. There's others, the large incumbents, the primes, so they say, yeah, we'll build it when there's a clear demand signal from the government, and we can use internal research and development that can then be reimbursed by the government later on, those IRAD dollars, right? Where are you all on that spectrum, and what is how does Apogee determine when it's go time on a problem?
Yeah, so we're 100% defense related. It used to be we were 100% DARPA. Now we're sort of probably 40% DARPA, 40% Air Force, and 20% other. And the way we think about it is it's a combination of find customers who care about really important problems, who are looking for someone to give them a new solution. They might already have an existing RFP. They might already have an existing acquisition vehicle that we can go after, and we want to partner with them. And then other times we see a problem that we think is really important, and we work with folks in the industry to help craft a program to go solve that. And one of the things that's interesting about the DARPA model is that DARPA PMs change over every 3 to 6 years. And so you might look at that and think, well, there's no longevity. You don't have an ability to sort of compound over time. But a lot of the longevity actually comes from both the support staff at DARPA as well as the performer base and folks like Apogee who can sort of see over time what differentiates really successful and impactful programs from ones that aren't necessarily as good. And we therefore think that we play an important role to go talk to program managers, understand what it is that they care about, and how can we find the intersection between what they care about and the problems that we think are important to solve and the constraints that will let things transition. And then we often work with a program manager to identify what is that path to solve this problem and how do they structure it, not only so that it'll solve the problem, but also so that the available companies can bid it. Because that's one of the problems that DARPA program managers, they're program managers. They don't actually build their technologies. They need performers, companies to come in and solve their problems. And if they don't structure their solicitations in a way that folks can bid it, then you can end up with a really good idea that can't be executed. And so we spend a lot of time working with program managers to help craft these ideas that can be executed well. And part of the rule is that when you help the program managers, everything that you give the program manager gets given out to everyone who's going to bid the program. So it's not just helping Apogee, it's helping everyone. And then our premise is, as long as we can remain competitive enough and have good ideas and deliver value to our customers, we're going to win enough of those solicitations that we can have a profitable business, even as we're relatively picky about what we do, and we have a weird business model where everything that we do is MIT open source license within the DoD. So we give it to the government with beyond unlimited rights. The government can do whatever they want with it. The commercial companies can do whatever they want with it. And we just really want to focus on impact and seeing our ideas get used.
It's a really interesting counterpoint to, I think, a lot of what the orthodoxy is about how software gets built or might get built for the Department of Defense. I want to hit on two things before we start talking about Stitches. The first is just your business model. So Apogee is a services firm, not a product firm. You're not selling software licenses. You are literally selling the expertise and time of engineers to build great, solutions. And then the second is the DARPA model, because I know that's second nature to you, David, but to a lot of folks who are listening to this almost certainly have never worked with and may never work with a DARPA program manager. And so I'm thinking maybe let's just touch on each of those very briefly. The first one, in terms of how you all work, Apogee is a services firm. How do you decide, when are you working as a prime on a contract? When are you partnering or subcontracting to a larger company? And how do you all think about the development and then sustainment of the things that you build?
Yeah. So my common theme will often be, we really try and pick whatever feels like it's going to be best for the government, because again, what we care about is impact and delivering that value. So when we think about priming or subbing, we don't care about it from the perspective of what's going to make us the most money or what's going to give us the most control. When we prime, we have relatively weak constraints on our subs. We tell them, you guys can talk directly to the customer. You can do other things on these problems. We're not there to try and create these artificial constraints to give us a boost in the market. And really what it comes down to, for example, is what's going to be the right path for a transition. So, for example, if there's a technology where there's a particular sensor or a particular sort of technology we need to build, and we need to solve the hard problem, and then once we've solved the hard problem, it's going to be, okay, how do you incorporate this to hardware and how do you get it on 1,000 aircraft? Well, there's going to be a lot of companies that are better at that last part than us. So we'd much rather find a company, usually a larger company, who's going to have the technology and expertise to make some of these things real and to get it on build the 100 boxes, the 1,000 boxes, or the 100 jets. And what we want to do is help them solve the real problem, make sure it's going to be resilient, make sure it's going to be reliable, make sure that it's going to actually work, and then give it to them and let them run with it and go scale it. There are other times when what we're trying to build is something that will get adopted broadly. And one of the nice things about Apogee and our business model is no one sees us as a threat. Because since we don't take IP on anything that we do, then we're not really eating other people's lunch. And so for example, the big primes often see us as, if they partner with us and they give us access to their real problems, we'll build solutions, then give it to them for free, and they can go make lots of money with that. And when we think about projects that we want to be adopted broadly, if Apogee primes it, because no one sees us as a threat, you won't naturally spin up antibodies to the architecture. And so it might be an idea that can then be adopted broadly by many different companies. And if the government sort of puts it out as something that they want to see get adopted, companies aren't going to scream foul. Whereas sometimes if one prime builds this new architecture, this new standard, whatever it might be, then all of the other big primes are going to be like, oh, well, this naturally is anti-competitive and this is giving them an advantage over us. And they're going to naturally resistant whether it's the right thing for the country or not. And so that's sort of how we think about it. And part of it is often who has the time and energy to prime. There's often a lot of things going on. There might be a lot of proposals in the work. And sometimes we'll do a 50-50 sort of cost share. Either of us could have primed. We'll take it this time, you take it that time. And we just build strong relationships that make that feasible.
In some sense, you almost sound like you're a nonprofit, which is not the case, right? You all do make money, but we
do make money. We do grow.
It's unique, certainly, the approach. And, the prime versus sub conversation, I think very often is detached from the reality of what that relationship really entails, which is being a prime does not just mean you're the bigger, better company. It means there's a certain set of administrative and logistical responsibilities that actually a lot of startup, we just put out some research on this a few weeks ago. If you ask companies, do you want to integrate other people's products and services and solutions into what you're building? Most new companies want nothing to do with that. But if you ask them, do you want to be a prime? Of course, everybody wants to be a prime because that's so it's kind of the opportunity to think to structure partnerships like the ones you're talking about, where if you have trust, if you have a good relationship with the other folks on the team, where you sit maybe doesn't matter quite as much.
Yeah, and I think that it is very easy for folks who are priming to not think about everything that needs to go into it. I mean, I love solving the actual technical problem and solving the hard nugget, but it's equally important to make training material and make things that will help folks understand how to use our technology. And I can't just assume that someone else is going to take care of that and that we're too small and we're not going to do it. It's really important to fill whatever role needs to be filled and address whatever the most important problem is to give our warfighters capabilities.
Absolutely. All right. So I think that is it's a nice transition to something that I think will make this a lot more real for folks, which is an example that David, when we connected, I'd been hearing about for years and didn't even know that Apogee was necessarily the brains behind it. But now that I do, I'm even more excited for this conversation, and that is the Stitches program. Well, before we talk about all of what that is and why it's so important, let's just start with the question of interoperability. And you alluded to it a little bit in your opening, but why is interoperability so hard for the Department of Defense?
Yeah, I think that interoperability is so hard for a couple reasons. One is simply scale, that the DoD is operating in a scale that few other organizations come close to or even appreciate. Second is the heterogeneity I talked about, where there's so many different players that are trying to feed the ecosystem. And part of what makes the US fantastic is that it's not a top-down centralized approach that just tells everyone what to do. It's trying to take these fantastic ideas from all over the place and pull them together into these great capabilities. And so you want to create flexibility and create space for innovations that no one has thought of. But then that can create challenges when you're trying to bring it all together at the end. And the third is that there are a lot of competing interests. There's a lot of big companies that don't necessarily see eye. They're competing. They're trying to make money, and that creates complexities. And then the fourth is the multi-level security. That when you're trying to operate across security levels, whether that's going from unclassified to secret collateral and TS collateral or SAP or SCI, there's a lot of different compartments and information needs to be protected. And it means that sometimes you're trying to integrate between things that can't know about each other. And as our joint forces with our various allies in NATO, with Five Eyes, various different parts of the world, you also get a flavor there where we're trying to integrate with our allies. And there's a lot of things that we're willing to share with them, but there's also things that are important to keep US only. And so it creates these challenges where you're trying to integrate across information boundaries, where on both sides there are political and legal reasons why things can't necessarily know about each other.
So it's kind of hard, I think, for a lot of folks to even conceptualize what this looks like today, right? We live in the world of, to me, a cross domain is I get a text message on iMessage that I drop in WhatsApp and then it comes on my computer because I'm still on the Microsoft ecosystem, not Apple. And that's it. You're just going from one program to another. But in practice, what this means is that there are places around the world where our military is literally still using floppy disks or burning CDs and DVDs and running them physically between buildings to be able to move information from one system to another, right? This is stuff that, there are people who are born today who have never seen a CD before. And that is how our military is operating in parts of the world. So big problem, right? Interoperability, allowing different organizations, American and non-American, to communicate with one another. Obviously, our alliances being a huge part of how we operate militarily around the world. So DARPA spins this initiative up called Systems of Systems Integration Technology and Experimentation, or SoSITE. Tell us a little bit about what that was and why did it come to DARPA of all places?
Yeah, so SoSITE was started out of this recognition that there's one approach typically to building defense systems, and that is you start with a problem and then you go clean slate design. You design a new solution, you build that solution, you test it against the requirements, and then you go field it. But increasingly, that can't keep up. It's really hard to build a new fighter plane. It's really hard to build a new piece of hardware that's going to be able to operate in a fundamentally adversarial environment. And SoSITE was asking the question of, what would it look like to start from a different operating point and say, you know what, we have a lot of things, be they drones, be they jets, be they ships, be they remote fire systems, be they comms boxes, and all of those things can do a lot of different capabilities, perform a lot of different mission roles. What would it look like to ask the question of, given a mission, how do we piece together the things that we already have in a new way to go solve that problem rather than going and building something from scratch? And it turns out that most of the ways that we do engineering, systems engineering, software integration, don't really work. Given that paradigm. And SoSITE was trying to figure out new ways of tackling that problem. And why DARPA? I think it was why DARPA because it's a problem that had been plaguing the industry for a long time and no one had been able to make any progress on it. Interoperability was not a new issue. It's something that had come up many times before. And the second is that it's joint. It's cutting across a ton of different silos, a ton of different program offices, which means it's really hard to point to one organization in the DoD that has this problem, especially a decade ago before things like JADC2 and other things like that existed to the same degree. And so for that combination of reasons, there was a cohort of people who decided to give it a try at DARPA. And Evan, our CEO and president, was part of pushing that program to exist. And then it kicked off in 2014. And the short version is it started in 2014. There were sort of two parts. One was focused on the systems engineering piece of how do you determine which components are going to be able to achieve which mission. And then the part two was, given that composition, how do you rapidly integrate them from a software perspective? We were a performer on part two, building the Stitches technology that we'll talk more about. And then when Rev Jones came in 2016, he realized that Stitches was really the piece that had evolved that was going to have the most impact, and refocused SoSITE to be focused on how do we make Stitches real and show its benefit, which then kicked off a multi-year phase two and follow-ons until it transitioned to become an Air Force program of record in 2021, which we'll get to.
Okay, so bottom line up front, what started as a DARPA program, and to be clear, the majority of DARPA programs do not make it to program of record, right? Like most are killed. It's actually something that doesn't that's not altogether different from the venture ecosystem, where you place some bets, you kind of put some money against it, see what happens, and then if things transition and find a customer, they survive, and if not, the teams kind of move on to a different topic. So this is one that has, the reason we're having this conversation, the reason it's on the Crossing the Valley podcast, is because it's one that actually did succeed in becoming a program of record. But there's a lot to the story before we get there. And I think, David, you mentioned some of this, that as the DARPA decides we're going to tackle this problem, how did the team come together? How do you think about who gets to, is this like DIU has the commercial solutions offering where you have a bunch of companies apply and then they kind of go through interviews and then one or two or three, depending on the need, get awarded, and they get a prototype agreement. Is it like a SBIR where you get a hunting license to kind of go find a customer? Or is this, more like a traditional kind of prime or a FAR-based contract where you have a prime that kind of builds a team? Tell us how that actually comes together.
Yeah, so DARPA puts out BAAs, they're broad agency announcements, and there's two parts to bidding a DARPA BAA. First is usually the folks who know DARPA and are in the ecosystem spend lots of time talking to the program manager before the BAA comes out to understand what it is they're looking for and to understand their perspective on the problem. Then the BAA comes out, and usually before then, you've figured out what role as a company, what part of the BA are you going to bid, and who are you teaming with? Sometimes there's teaming conversations that happen, but usually you've sort of figured out the teams, you figured out which part you're going to go after, and then over about 45, 60 days, you're submitting a proposal, which has a combination of a long tech volume and then a cost volume. Usually they are FAR-based contracts, although there's definitely an increase of OTAs and other things going on right now. And DARPA doesn't restrict who can bid. So you'll get big companies, the Lockheeds, the Northrops, the GDs bidding for things, and you also get small companies bidding for those same pieces. And depending on what the scope and what the dollar amount is, you have to be able to articulate how you're credibly going to be able to execute. So if Apogee bid by themselves that we're going to build a new aircraft, the government might be skeptical in that. But we were able to articulate a both plan and a team for how we were going to build a different software tool chain to tackle interoperability. The government thought that was convincing and then selected us, and that's how it got started.
Very cool. What can you share about the other components of the team? How did you all think about who you wanted to bring into that conversation?
Yeah, so Stitches touches on a lot of different fronts. And I think when I talked, for example, about bringing together multidisciplinary teams, that also means that you're cutting across companies. So Stitches is a tool chain that we'll talk about that has fundamentally new approaches to compilers. So we need folks who are going to be compiler experts and folks who will be able to write new ways of rendering software. We also needed teammates who understood formal methods to be able to sort of create guarantees and analyze some of the work that we were doing to show that it's going to be correct and secure. And then over time, we also want partners, be that subcontractors or co-contractors, who really understand the mission problems in ways that we might not, and can help make sure that we're building something that will get used.
Absolutely. All right. So build this team, get in the game. Stitches, I guess we've referenced this a number of times here, and I don't think we've yet defined it. So system of systems, technology integration toolchain for heterogeneous electronic systems. For anybody who's listening and not reading that is quite a mouthful. We also talked, it comes all the way back to how we started the conversation, David, around, multiple heterogeneous systems. And then we talked about tool chains. You've got the team in place. What happens? How do you kick this off? How do you begin to eat this proverbial elephant, which is, truly like any two systems could be connected in the Department of Defense, and there are tens of thousands, if not more, systems?
Yeah, so I think it's useful to as a prelude to this, to define what Stitches is and how it works to be able to give a bit more context. So the problem of interoperability, there's two large camps of how interoperability has traditionally been tackled. One of which was, if we think about something like the F-22, there were a lot of component providers who made their own decisions in terms of software interfaces, APIs, things like that. They didn't necessarily work together. And then it was up to the prime, in the case of the 22 Lockheed Martin, to basically rewrite the software to try and get all of these systems talking to each other. And it worked. This 22 is a fantastic platform. There's many other cases of it working phenomenally, but it takes a long time. It's expensive, and it's also can be hard to change. When you write software that makes things as coupled as they often are or end up, it can be very hard to change them, incorporate something new. So there was this question of, well, how do we make it easier to integrate things so that the primes don't have to rewrite it, and when something new comes online, it's sort of plug and play. And so then there was a movement to global standards of, if we can all agree on what the common set of APIs should be for our suite of applications, then it should be really easy, right? We're just going to build to those APIs, and then because we all speak the same language, it'll all just work. And I think we now have enough data to really understand that global standards aren't going to pan out. And they don't pan out for a couple of reasons. One of which is the global standard seems great until you have to change it. Because when you have something that, say, an entire service agrees on, trying to change it means it touches a lot of players, and it can take a lot of effort. And in the DoD, global might not just mean one service. It might mean the entire US military. It might mean all of NATO. It can get very large. And as we see in much of the world today, getting that many people to agree on a change can take a very, very long time. The second piece that wasn't as obvious, and we collected a lot of data on this early in the SoSITE program, is that by trying to be so broad, the global standards actually introduce a lot of ambiguity, because the messages are effectively trying to be everyone to everyone, or everything to everyone. But it means that, for example, there'll be a lot of optional structures where the message could be a line of bearing, or it could be a radar message, or it could be an IR message. And by having all of that ambiguity, you get two problems. One of which is it can be very, very non-performant at runtime. You get some of these global standards, you actually do like trillions and trillions of checks at runtime just to figure out what message it is before you even process the data, which is crazy. The second is it can be very hard to integrate, because how I interpret this ambiguous spec might be very different than how you interpret this ambiguous spec. And there usually isn't very good documentation of how did I interpret and implement the spec. And so you get a lot of people needing to comb through documentation and try and understand it before you can do the interoperability. And you'll plug systems together that you thought would work and then discover that they're completely incompatible. So global standards have these problems, didn't work. And so the question was, could we come with a different approach? Can you get the sort of scalability that we want from the global standard in a way that doesn't actually require agreeing on a common interface up front? And that was where Stitches came in. And the realization behind Stitches, when we think about common interfaces and what allows this, the commonality through global APIs, the common APIs, the global APIs, were usually too big and ambiguous that no one actually used them as their actual interface. They took whatever their internal representation was and then transformed it to the global representation, and then wrote a transformation from the global transformation to the other person's representation. And so it was this composition and reuse of transformations between different formats that actually gave you the interoperability. So once we realized that we could take that idea, get rid of the global standard, and instead build a ring structure or a graph structure where each of the nodes in the graph are a different representation, a different message interface, a different way of representing information in the world. And then the transforms are these, define the differential semantics between those different representations. And so the heart of Stitches is what we call the field and transform graph, this way of defining representations, defining transformations between different representations that you can then chain together to basically auto-generate long chains to give you interoperability between systems, even if don't have a direct connection. So then the second part of Stitches is a glorified compiler that takes this field and transform graph along with a system of systems specification, basically a statement of these are the systems that I want to interoperate today. And then it auto-generates glue code to let those different systems interact without them requiring a common API. And so Stitches is this field and transform graph to define these representations and the transforms, and then a compiler to auto-generate very efficient software to let those things talk. And the key is that we're not using the literal runtime, the systems as middlemen at runtime, nor are we using the sort of intermediate specifications through some long chain in the path. We use modern optimization and compilation techniques to generate very, very efficient point-to-point pieces of software that you can then load and run, which leads to a lot of both security benefits, which we can talk to, as well as very, very performance code.
To summarize this, I think what you're talking about is the ability to look at a variety of different kinds of information to detect kind of what kind of information it is, and then to do some things with software. So now there's and this is a piece of this, right? A lot of times when you talk about multi-level security or you talk about cross-domain solutions, the conversation immediately goes to policy. People will immediately start talking about, well, we have policy challenges as a government. And what you were able to do was to say, we're not going to spend our time up front fighting policy battles. We're going to look at the system as it is. We're going to look at the ecosystem as it is, and we're going to figure out what is possible with software within the confines of that process. And so I think the crucial insight here is that historically, I think you're absolutely right. Most people have attacked this problem by saying, well, if we could just have a universal language, if we could just have a universal standard for everything has to be, all data created has to be formatted in this way. And then we can use that to kind of talk across the world. And you guys said, no, we're going to just understand that that is a losing battle, that all that's going to produce is yet another language, another typography, another kind of format. And we're going to say, no, we're not going to try to change things. We're going to try to understand what they are and then manipulate them in such a way that they can be understandable to other systems. And that maybe sounds simple, but that is such a massive insight and a change in the way the Department of Defense has operated.
Yeah, and I think that it's really this idea of how do you let each community, each warfighter for a particular instance, pick the representations that make sense for them at a given moment, rather than trying to predict it up front. And that gives you a lot of flexibility to then adapt to the real problem and build something that's going to be much more performant, and then can continually evolve over time when people come up with new solutions, new capabilities that you need to integrate, instead of them being limited by the fact that, oh, we picked the wrong API and now we can't support this new information. Instead, there's a way for them to auto-generate the software they need and then do the set of incremental upgrades to slowly over time leverage the new functionality as they upgrade each of the different parts of the system. That's
great. And let's talk a little bit about people. I think there's two pieces to this that I'd like to explore a bit. The first is, you were talking about your customer discovery process, your research process, you're going out there and learning about how these different formats worked and how information flowed. And so I'm curious what you can share about kind of the early user group or user groups that you all were actually working with. You don't have to name names, so to speak, other than to say, like, how did you kind of say, all right, did you build for all use cases at the same time? Or did you narrow down on one or two to say, hey, we're just going to follow this thread and then see if it's generalizable?
Yeah, so the first couple years of the Stitches program were all about how can we prove this idea of this field and transform graph and show that it's feasible and show that it's applicable to the various problems that the rest of the effort was funding, which were largely Air Force, and a lot of you can think about as the distributed kill chains that are very of interest today, of how do you stitch between new sensors and fusers and displays, sensors and comm systems, go between multiple platforms, and how can we show that you can build those distributed kill chains in a way that you actually are embracing the heterogeneity and composing things that people hadn't thought were possible. And one of the things that was most key for building traction of Stitches is that early on, we built this software that suggested it was possible. We made training days and demo days that let people sit down at a computer, walk through it, get a feel for how it works, and see it. But it was still largely a theoretical argument that because we had this graph structure, because we had this reuse, that you should be able to do things faster. And what Rev Jones, who was still the program manager for Stitches, he was a Air Force pilot, then test pilot, then acquisitions are. And what he really realized was the only way we're going to convince people is if we show them. And so starting between 2 and 3 years into the DARPA program, which is crazy for DARPA, every 3 to 6 months, Rev took us to a new location with a new set of hardware, a new set of companies, and we got 3 weeks. The first week was bring the systems, get them powered on, understand the systems, the subsystems themselves. So an individual sensor, an individual tracker, an individual planner. The second week was, okay, Rev would on a board say, this is the composite capability I want. And before that Monday when he wrote it, none of the team who was integrating this had any idea what composition we were going to make. And this was part of the game of the claim is you can do this faster. A week is a long time, but also a very, very short time from a DoD perspective. Can you integrate new things in a week? And we got a week to get all the software in place. And then the third week was field tested. Was no joke. Okay, we're going to start actually flying planes. Real data is going to be flowing. Does it work? And as you can imagine, the first one, Stitches broke all over the place. The hardware broke all over the place. We had issues where we had to the cooling system wasn't working on a pod, so we were duct taping fans to cool things. We could only run for 5 minutes at a time. There were lots of growing pains because this wasn't something that the DoD was used to. But by Gauntlet 4, after 8 days had integrated 24 subsystems onto multiple planes, and were doing flights to show rapid retasking, sort of automated retasking of systems for distributed strikes and things like that. And prior to that, people sort of questioned, is Stitches actually going to work? Is it going to scale? But the minute we showed the 24 systems and the multiple planes, multi-level security integrated in 8 days, everyone went, okay, we now believe this. Now it's just a question of how do we get this to the hands of more people, and can we go from the sort of team that built the tool can do these things to a wider swath of folks can use this tool even if they don't understand it deeply. And so then what we did is we slowly moved from, okay, the Apogee team is really driving these events, to having software maintenance squadrons and folks from within the military who were going to be having to maintain the software running the events. And my favorite story with that is at Gauntlet 6, we were doing interoperability of C2 systems. And because a week wasn't hard enough, on Thursday of that week, one of the office directors from DARPA came in and said, okay, here's a new mission. I want you to do this mission by the end of the day. And he didn't think we were going to be able to do it, so he didn't even come in later that day. He came in the next morning and we're like, yes, we're done. And he was like, okay, that's cool, but I assume Apogee were the ones who built it. And Evan and I were like, actually, we were working on something completely different. And one of the fellows from the software maintenance squadron put up his hand and said, actually, sir, I'm the software maintenance squadron for this set of platforms, and we're the ones who did this. We barely needed to ask any questions. And that's what we love to see, because Apogee, we're not going to scale and solve the long tail. We need to build tools that others can use, and we want to empower the warfighters because they're the ones who deeply understand their platforms and their problems, and we don't want them to have to call us to try and change something. We want to empower them. And so being able to get to that point was incredibly exciting and really helped build the momentum that this was something that could actually be used broadly and solve a lot of key problems.
That's a remarkable story, and it's got to feel amazing. You're teaching them how to fish as opposed to, just kind of showing up with the solution, and that's incredible. And I think it speaks to where we're going next, which is really around what transition means and what it looks like in this context. So you talked about, first off, what an incredible construction of a program by Rev Jones, just in being able to bring people along, as you go, just hearing that. And one of the themes kind of on this program and many others is just how important having a true champion for some of this change inside the ecosystem really is. And
Absolutely.
I think that's just case in point. Like, you don't get to this point without somebody like that who's in uniform, who is credible in being able to bring folks together and kind of and put their name on the line to make it happen. So that's an awesome kind of teaching example. And when we talk about, I said we were going to talk about people. We talked about Rev and that piece of it. As you think about kind of how you all looked for a home for the program, this sounds like something that just about any office in the DoD could have been like, yep, this is useful to us. How did you all, Rev, DARPA, how did you all think about finding a long-term home for the program?
Stitches is actually very weird from a DoD perspective, and so finding a home was not as easy as you might think. And the reason is because the DoD is built around buying capabilities. They buy a plane that you can fly. They buy a sensor that you can load on something. They do buy software, but it's usually software that then plays a mission role. And fundamentally, Stitches is not a runtime weapons capability. It's a tool chain to generate capabilities. And this is an idea that we think is increasingly important for the DoD of how do you build what we call these generator technologies, where the way that you solve adaptability is not by having people change things over and over and over again, but you build tools that make it very easy to auto-generate the next instance tailored to what it might be. But the DoD really doesn't understand how to buy generator programs. And it took a long time to figure out where it was going to live. And DARPA, seeing the benefit of this technology, created effectively a bridge program where they held it for a number of years until the Air Force could really figure out where to put it. Where we ended up is the sort of Rev Jones is dual-hatted to AQL, which is the acquisition part of the Air Force, as well as the 350th Spectrum Warfare Wing, which is a place down in Eglin where they largely are building mission data files and which is software that basically defines the EW techniques that different platforms can use. And there's a realization that the way we're currently trying to do mission data files doesn't work because the timeline is too slow. The time from a new threat appears to when we're able to adapt to it is much, much slower than it needs to be. And so there's a movement to sort of change how do we do mission data files. And one of the things that's part of it is if I have a new technique, why do I have to manually port that EW, that electronic warfare technique, manually to 30 different systems? Why instead can't I have a tool that will figure out how to let me take this technique and map it to a whole bunch of systems? And while that's not the instance that Stitches was solving, Stitches is sort of in that family of problems. And so when the new Spectrum Warfare Wing got stood up to sort of think about this differently, there was a colonel named Dollar Young who was forward-leaning and realized we can house Stitches, and even though Stitches is going to help many different parts of the Air Force and other parts of the joint military beyond Eglin, beyond electronic warfare, this is a home that can allow it to sort of get a foothold and then branch out from there. But it's definitely a journey, and it's something that we're continually trying to work on. And it ends up being that there's from a transition perspective, that there's a single contract dedicated to the development of Stitches. And then folks who want to pay for applications can either give a contract directly to an organization to use Stitches to build them a capability. Sometimes that's Apogee. Sometimes that's many other organizations. We'll come back to that. Or they can sort of give money to Rev and use his contract vehicle to fund folks in the Stitches ecosystem to build them capabilities. And so there's a lot of different, there's a lot of work that has to happen on the government side and on the contracting side to figure out how do we flow the money in a way that can let us respond and address these problems. And I think that one of the things we've definitely learned when you go back to the people side of things is that tying the contracting folks in tightly is incredibly important. That some folks treat contracting officers as either barriers or folks you only talk to when there's a problem. But we found that if you take the time to really explain to them what is the mission, what is it we're trying to do, why does this look different, why do we need to move quickly in ways we weren't expecting, they're in the DoD because they deeply care about the mission. And when they can understand and when they're brought in as part of the team, they want to help us find an approach. And the second piece of that goes on the security side, where one of the other issues that people will often tell you for interoperability that plagues the DoD is what are called ATOs, authorizations to operate, of how do you get permissions to connect one system to another. And ATOs come from a good place. The idea really comes from caring about the cybersecurity side of things. And if I have a system that gets compromised, I don't want to just plug it willy-nilly into a whole bunch of other systems and create problems. And so, again, the security folks, they come from a good place. They care about the mission. They're trying to protect things. And when you take the time to understand their problem and craft the solutions in a way that they can get behind, then you can make ATOs much, much faster. And so the people side really is important of how do you find the different players to build that composite ecosystem to help push something that's new and different along, because no one player usually quite has the full set of authorities to make it happen.
There's one more group of people that we didn't, actually there's more than one. We didn't talk about Congress, but there's one particular group of people that we didn't talk about that I'm really curious to hear about, and that is Apogee. What does transition actually mean for Apogee? Does it mean that the revenue goes away and y'all have to go find another program? Or what? Like, how do you all see transition as a company?
Yeah, so the first thing I'll say is while we were and are the main developers of Stitches, the Stitches ecosystem is very much beyond Apogee at this point. We talked about the fact that we don't take IP on Stitches. It has an MIT open source license within the DoD. Literally anybody with a cat can go to www.stitches.mil, download all of the source code, all of the documentation, all of the integrations we've created. And there are dozens of companies that use both internal funds as well as external funds from any number of DoD capabilities to build, or DoD entities, to build capabilities using Stitches. Sometimes we know about them. Sometimes the extent to which we know about them is that someone sends us a note and says, I'm using the tool, I hit this error, what does it mean? How do we get around it? We take a look at it, we send them our best thoughts, we never hear from them again. And so it really has grown to be this very large community, and that's what we're excited about. So transition means two things for us. One, there's still a lot of work to do, and Rev pays us through a transition contract through the Air Force to keep developing the tool chain. Sometimes that means adding like fundamentally new capabilities that people hadn't thought about before. One of the things that we're doing for him, for example, is how do we get Stitches to the point where we can auto-generate cross-domain solutions that are sort of can be formally verified that they don't let through information that they shouldn't. Not something Stitches currently does. There's new research that needs to be done, but Rev wants to pay for that because he thinks it's critical to sort of unlocking a lot of the potential that Stitches has. And then there's another piece where there's a lot of different entities that will fund Apogee directly to build transition capabilities for them. So an example of that I can talk about is there's a Bravo hackathon series that the Air Force started, which is we're going to get a couple hundred folks in a single place at the sort of secret collateral level, and we're going to build capabilities that solve important problems that we can transition. So there's a bunch of folks from Apogee that are going out to PACOM, going out to Hawaii next week to participate in one of these to try and help build capabilities for the folks out at PACOM that they can use to solve any number of their problems. So the one half of what it means for Apogee is there definitely there is pull from now a different community that we have to get used to, the different funding cycles, the different transition schemes. And we're really excited about that. And we're excited to help folks use stitches to build these capabilities. And then it also means that how do we now solve the next problems that sort of are a bit beyond Apogee or beyond stitches? Work on sort of new DARPA programs that are solving problems that will be able to leverage stitches, but go beyond what it's currently doing. And so we're always excited about what's that next problem and how do we solve the next big idea and make progress on it, such that as stitches matures and other folks are able to use stitches without us, we can spend our time and energy building the next thing that will then follow in stitches' shoes. And the hope is that we'll be able to leverage stitches to make the transition of the next thing easier, but time will tell.
You're building the ecosystem that you too will benefit from, that you want to take part in. I think that's such a nice, poetic kind of way for us to bring this to a close. David, we're just about over time. I want to be respectful of yours. Any final thoughts for us on kind of, from all of what we've gone through today, the Apogee experience, the Apogee model, bringing this from kind of concept to major program that is now affecting the conduct of military operations and just general operations across the Department of Defense. What does the future of defense technology look like from David Gerson's perspective?
I think it's a very exciting time. I think there's a lot of excitement, a lot of new ideas, and we're moving into a world where rather than spend a couple decades building a single capability, we're constantly developing new capabilities by composing things in different ways, which means the rate of development and the rate of change is ever increasing, which is exciting. And I think that the one thing that I would leave you and listeners with is, if I can make a plug for the joint capabilities, where joint meaning across the different services, is really important for the DoD, cutting across services, cutting across companies. And I think what we've really seen on Stitches and in other parts of the community is the value that comes when you make data open with minimal constraints, when you create your software that is easy for others to sort of pick up, use, deploy into the right environments, when you keep the barriers low for new organizations to participate, and that even as the rate of technology changes and we're getting faster and faster at adapting, that we keep the missions in focus, and that we always focus on what is the mission value that's going to come from this and not get lost in the exciting technology. And I think that if we keep those sort of as North Stars for the community, it's going to be very exciting times ahead.
Fantastic. I couldn't have said that any better. I appreciate, David, everything that you guys are doing, the impact that you're having for the mission. Not a moment too soon. This is you guys are working on huge problems and making a significant impact. So thank you for all of that. And thank you for taking the time today. Your wisdom, your insight, and your experience will be hugely valuable to our listeners. So really appreciate it. Keep up the great work.
Thank you. And thank you for letting me tell Apogee's story and for trying to build this podcast and many other pieces to make it easier for others to get involved in the defense industry.
One team, one fight.
Absolutely.